first, we're going to explain the kinetic molecular theory. It states that particles are in constant movement and frequently collide between them, and also with the walls of the container where they are. If molecules are small in relation with the distance between molecules, the molecules combined are insignificant. The volume it's really small. Particles didn't exert force one to another. Collision between them are elastics, and the average kinetic energy in particles the temperature is measured with kelvins. So we are going to make an example, an exercise. So here we have the variables that we use in the kinetic molecular theory. The P is for pressure, as already know, and it is equal to we have T for temperature that I already mentioned. It is in kelvins, represented by the K, that it's equal to degrees Celsius plus 273. The molecular mass, it's 1.429 mole, and the volume, it's equal to 1 liter equals to 100 milliliters. So here we have methane, argon, and helium. They have the same temperature that is measured in kelvins, that means the K, and the pressure. The pressures could be different. This is less and higher pressure. So which one do you think that have the highest average kinetic energy? The one that has less pressure or the one that has more pressure? The answer is that they are equal, because its temperature it's the same for all of them. So they have exactly the same average kinetic energy, that it's proportional to kelvins. So the Boyle's law was invented by Robert Boyle, and it says that pressure and volume are inversely proportional. So if one increases, the other one will decrease, and inversely. So gas particles bang against the sides, and the gas pressure will be higher. So in a graph we could see it like this. This could be the pressure and the volume. So this if pressure is increasing, volume will be decreasing, and inversely, if pressure is lower, volume is higher. But it needs to be always like that, one higher than the other one. And in a draw we can represent it like this. We have two recipients, one with less volume, and the particles will be more compact, so it has more pressure and less volume. And in this one we have less pressure but more volume. So now we are going to do an exercise. Well, the problem will be that a recipient of 2.5 liter container has a pressure of 4.68 tm, and the volume decrease to 1.6 liters. So we need to discover the new pressure. So as we could see, the volume decreased, so the pressure needs to increase. The formula that we will use for this exercise would be P1 B1 equals P2 B2, and B1 it's equal to 2.5 liters. P1 it's equal to 4.6 atm. B2 it's equal to 1.6 liters, and the operation would be like this. That it's equal to 7.19 atm if we made the division. So now the Charles law, it's really similar to Boyle's law, but it says that the volume is of gas, it's direct proportional to the absolute temperature. The equation that we use with this law, it's V1 over T1 equals V2 over T2. And if we had a recipient, a container with less pressure or higher pressure, so the volume, in more volume, the temperature will be higher because they are proportional. Graham's law states that diffusion and effusion of gases are inversely proportional to the square root of their respective molar masses. So the formula is R2 over R1 equals to square root of molar masses 1 over molar masses 2, and show the motion of the ratio of gas A speed and gas B speed. So it is equal to we can say that if M, that it's molar masses, increase, R will decrease and the effusion will increase. This law was invented by Thomas Graham at 1848, and now we are going to do an exercise for practicing. So the exercise is how many times faster can be in E, that is neon, atoms travel than Xe, that is xenon. So it will be an equation like this: rate neon over rate xenon equals to square root of Xe and E equals to 13.1 0.99